and welcome to my three-part series on solar panel installations on your boat. I'm Beth. I am an ABYC Marine Tech certified in diesel, electrical, and systems. The series is in three parts. The first part, we're going to go through the considerations you should think about before you actually order your system and start doing the install. Part two, we'll go through the different components of my installation here and put them together, and then in part three we will wire everything up, put the panel outside and hook it up to a battery, and then check how well it's doing. With your solar panel installation, you want to be sure that you understand how much it's going to put out, what it's going to give you in terms of recharging of your batteries, and in order to really understand that, first you have to understand what the loads are on your boat that are drawing down your batteries, and then you can plan for the size of solar panels that would actually recharge those to a level that you can be happy with. You have to start out with a little bit of boat math. Now everything on your boat that's electrical is going to have a draw. Most everything will have a manufacturer's stated draw, either expressed in watts or in amps at a certain voltage. And so first off, you need to understand how to convert watts into amps and vice versa. So we'll go through a little bit of how to do that. It's really simple math, nothing complicated. First thing you want to know is watts equals volts times amps. And by doing a little algebra, we also can see that watts divided by volts equals amps. Okay, so I'm going to use a couple of simple examples to go through, and this is a very simple boat. We're going to assume that this boat has two things on it. It has an anchor light and it has a fridge. Okay, so the anchor light, I look at my specs, and my specs say it's a 12 watt anchor light. So if I take 12 watts, I divide that by 12 volts, I'm going to get 1 amp. So it's drawing 1 amp, and it's on for how many hours a day? I'm going to say 12 hours. So my draw in a 24-hour period is going to be 1 amp times 12 hours equals 12 amp hours. Okay? Now my other piece of equipment is a refrigerator. And if you have one, you know the compressor comes on, it draws more juice. The compressor goes off, it draws less juice. But generally they'll tell you what the average draw over a 12 or 24-hour period, what's the average hourly draw you can expect, okay? And in this particular case, they're telling me it's 5 amps at 12 volts, okay? So this is a simpler I don't have to do this conversion thing. I already know it's 5 amps. So I got 5 amps. And how many hours is my fridge running? Well, it's running 24 hours. So that gives me 120 amp hours. This is in a 24-hour period, okay? So now I have 132 amp hours that are being taken out of my battery bank in 24 hours. So I need to figure out what my solar panel is going to put in, and then I can see whether I'm going to be happy or not, or I'm going to have to do something else. So I have a solar panel here. So here's my solar panel for this example. It's a 50-watt panel. On the back of it are the specs. You can see, if you scroll down the list, optimum operating voltage, 18.3 volts. Optimum operating current, 2.73 amps. You need this information as part of your sizing of your system. So our solar panel puts out 2.7 amps at 18.3 volts. Now this is going to go down to a controller. My controller's smart. It charges my battery in stages, but I'm going to say for the purposes of me trying to figure this all out, that it's going to average, the voltage that's going to go into the batteries is going to average around 14 volts. So I need to convert this so I can figure out how many amps am I getting out of that thing at 14 volts. So we know from up here, watts equals volts times amps. So we're going to do this. We're going to multiply 18.3 volts times 2.7 amps. It comes out to 49.4 watts. Now I'm going to take that 49.4, divide it by 14 volts, and that's going to give me 3.5 amps. So my panel's out there, it's summertime. I'm going to say I'm going to get 8 good hours out of that panel. Maybe I will, maybe I won't, but I'm going to use 8 hours as my example. So 3.5 amps times 8 hours gives me 28 amp hours. Well, I need 132. So one of these panels, while it will contribute to charging my batteries, is not going to take care of my entire load. So it turns out that if I had 5 of these panels, I would have 5 times 28. That equals 140 amp hours. That would give me enough. So that would be 5 of these 50-watt panels. Now, panels are different types put out different amounts, but what you need to know before you go and buy your panel is what's going to fit in my space, what kind of power is it going to give me, and will it work for my boat. So this is the basic kind of calculations you need to do to figure that out, so that you're going to be happy in the end with what you're buying and what you're installing.